and welcome back to Gurjyoti classes, and I'm here with the first chapter of CBSE class 10th real numbers. So let's start with the video. First thing to learn in this chapter is Euclid's division lemma. Now I'm giving an example to explain it. Let me read what is written. How many means we want to find some amount of something. So if counted in pairs, 1 will remain. Means if counted in pairs means the quotient is 2 and the remainder will be 1. If counted in threes, 2 will remain. Means if the quotient is 3, 2 is the remainder. If counted in fours, 3 will remain. Means if the quotient is 4, remainder is 3. If counted in fives, 4 will remain. Means the quotient is 5. If the quotient is 5, 4 will be the remainder. If counted in sixes, 5 will remain. Therefore, if the quotient is 6, then the remainder will be 5. And if counted in 7, 0 will remain. So, if the quotient is 7, then the remainder will be 0. And he says that it is not extended above 150. Therefore, it is equal or less than 150. So can we understand in anything? It is a mathematics chapter, so let us write in the form of mathematical equation. The first statement says that if counted in pairs, 1 will be the remainder. So a will be 2m plus 1. Similarly, a will be also be equal to 3n plus 2. Similarly, 4o plus 3, then 5p plus 4, 6q plus 5, and 7r plus 0. And from this, because a is equal to 7r plus 0 means the remainder is 0. So a is a multiple of 7, or you can say that a is divisible by 7. Okay, so a multiple of 7 which satisfies all the equation from first one to the last one will be 119. You can see, give it a look, solve it, and you can find it. Okay, so let's move further. So did we understand the Euclid's division lemma? Yes, the given positive integers a and b, okay, there exist a unique integer q and r satisfying a is equals to bu plus r. Here a and b are the two numbers and q is the quotient, r is the remainder. When 0 is less than or equal to r and b is greater than r, okay, or you can say r is less than b. Let's see some examples which makes the Euclid's division lemma much clear to you. Therefore, 10 and 3 can be written as 10 is equals to 3 into 3 plus 1. So here a is 10, b is 3, q is 3, and r is 1. Okay, so next example is 57 and 5 can be written as 57 is equals to 5 into 11 plus 2. Means we are just doing the division, finding the quotient and the remainder, and writing it in the form of an equation. We can find the HCF using the Euclid's division lemma. How? Let the two numbers be 135 and 225. Okay, we are taking an example first of all to understand it. So 225 and 135. Since 225 is greater than 135, we will write 225 is equals to 135 into 1 plus 90. Yes, then what will happen here? The b and the r will become the two numbers. B and the r, which is 135 and 90, will become the new two numbers, and 135 will be equal to 90 into 1 plus 45. As you know well, again the same thing will happen, that 90 and 45 will become the two numbers now. Means b and r will again become the two numbers, which will be 90 is equals to 45 into 2 is equal to 0. Okay, so until and unless 0 is came as the remainder, we are going to do this. Okay, means we are going to form the equation and then take b and r, again form the equation, take b and r, again form the equation, until we have found 0. But where's the HCF? Okay, the HCF will be the last value of b. in the last equation, whatever the value of b is will be the HCF. In this situation it is 45. I hope you have understood. Let's see another theorem. Every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime numbers occur, and this is fundamental theorem of arithmetic. For example, 90 is a composite number which can be written as 2 into 2 into 3 into 3 into 5, where 2, 3 and 5 are prime numbers. So a composite numbers can be expressed as the product of prime numbers. 90 is expressed as the product of prime numbers, those are 2, 3 and 5. Similarly, 88 is expressed in the form of product of prime numbers, those are 2 and 11. This is very easy. You just need to take out the LCM, and not the LCM but the factors of the number given, and you have to write it in the form of written for 90 and 88 but in ascending order. Okay, then note a formula. There is a formula which relates LCM and HCF, where LCM is equals to product of given numbers divided by the HCF.